All right, today we're going to be starting to talk about graphing function rules. And if you remember, I mentioned this yesterday, but function rules is really just an equation. Okay, so for example, this equation that I give you right here, just so we get used to our vocabulary, you might see this referred to as our rule or just our equation. Okay. And basically what we're going to do today is we're going to be looking at equations, and the equations tell us how my independent variable is related to my dependent variable, how my x is related to my y, and we're going to use that to graph our linear functions. So if you look at this chart here, this is how we're going to do it to start, and eventually I'll teach you an easier way to do this, but to start today, we're just going to use our chart and learn it this way. So you look at what's in front of you. Here I have my inputs. I have my list of x values. Over here, I have my rule again. And my rule again is telling me how my x is related to my y. Okay? So if you think about this like a machine, all we're going to do is we're going to take our input, right? We're going to plug it in for our x value, and we're going to see what my equation spits out. Okay? That's my dependent variable. So if I just plug in, like I said, a -1 here for x, okay, so it's replacing the x. If I plug that in, I'm going to get a 3, okay? And then remember, we can write that as an ordered pair. So my x value was -1, my y value was 3. Let's try the next one. I use the same equation, but this time, instead of plugging in a -1, I'm going to be plugging in a 0, okay? Plug in a 0, I solve, I get a 1. So as an order pair, we'd have 0, 1. Okay? You would follow this trend, right? We're going to try the next one. I plug in a 1. We solve, we get -1, so I'm left with 1, -1. And last but not least, I plug in a 2. I solve and get -3. So I have 2, -3, okay? So that's just us plugging our values in and seeing what we get from our chart, okay? Now, let's graph the points that we just found. So I'm going to go in order, top to bottom, okay? So the first one I see is -1, 3. And just as a reminder, when we graph, we always start at the origin. The first number, -1, tells me where to go left or right in the x direction. So it's -1, so I'm going to go to -1. And then the y tells me where to go up or down. It's a +3, so I go up 3. I'm going to plot a point right there. Okay. Our next one is 0, 1. Then we have 1, -1, and 2, -3. All good mathematicians connect their dots when needed. So I connect them. And notice we have our linear function, okay? How do I know it's a linear function? Because it's a straight line. That's a review from yesterday. Okay. All right, go ahead. I want you to try this one. But before you do, let's talk about what x values I'm going to choose. So if you see here, I'm not giving you what x values to pick from. Okay. The one x value that I always choose anytime I'm graphing one of these from a table is 0. Okay. Notice where I wrote it because we're going to do another number before it. But 0 is a great number to choose because it's easy and it's right in the middle of my graph, right? It's kind of like a starting point. Okay. Now, the first number I choose is going to be a -2. And the reason I choose that number is because of this little 2 in the denominator. Because I have a 2 in the denominator, I really don't want to deal with fractions. So if I plug a 1 in here, I would just have a 1/2 minus 1. I'd be dealing with fractions. I can avoid that if I want. Okay. So in other words, if I plug in a -2, my denominator is going to go away, right? These are going to cancel. So I want to pick x values that are going to cancel out this 2. In other words, I want to pick multiples of 2. So I'm going to go 2, 4. Okay? If I wanted to, let's say this was a 3. If this was a 3, I would have picked 3, 6, 9, right? If it was 5, I would have picked 5, 10, 15, right? The x values are going to change depending on what my denominator is. All right, so using those numbers, I want you to now go ahead and graph this function. All right, so hopefully we got to here, and I guess my numbers aren't spit out as well anymore. So let me see here. I had -2 first, then 0, then 2, then 4, okay? And we get these points. All right, so now let's graph it. So I've got -2, -2, 0, -1, 2, 0, and 4, 1. I connect my points. Okay? And I'm left with a linear function. Okay? All right, let's look at the next page. Okay, so here we have our problem. It says a function rule W represents the total weight W in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 feet cubed, what is a reasonable graph of the function rule? Okay, so here we're introducing this idea of a reasonable. Okay, so in other words, I'm asking you, what is a reasonable value for C? Well, the key lies in what our variables are. So C, I find out in my problem, is talking about cubic feet of concrete. Okay, so cubic feet of concrete. Okay, and then W is talking about weight, specifically total weight. Okay, so as we think about this, again, what's the number that I always want to use for sure is 0, right? Why would I not want to choose negative values of C? Well, I wouldn't want to choose negative values of C because it doesn't make sense to have negative cubic feet of concrete, right? That would not work. We don't want negative values of C, so I'm only going to go up by positives. Now, I'm also not going to go up by 1, 2, 3, 4, and the reason for that is because it says that my total amount that I can fit is 200, okay? 200 is a lot, okay? So I'm going to just plug in. I'm going to go by tens, 10, 20, 30, okay? All right, now we're going to pause, and if you remember, when we were plugging them in by hand, plugging our numbers in by hand, it was very tedious, right? It's not fun. It takes a long time. I'm going to teach you at this point how we can use our calculator to do this, okay? So I'm going to kind of go off to the side and write our steps down. But basically what we're going to do is first, your first step on our graphing calculator, you're going to hit second, then plus, then 7, 1, 2. Okay, what that'll do is that'll clear your calculator. I'll get rid of anything in there that might mess up our graph here. Okay, so second, then plus, then 7, 1, 2. Then you're going to find it's a yellow button at the top of your screen, top left, right underneath your screen that says Y equals. Okay, it's a yellow button, Y equals. Once you click on that, you should see a screen that says Y equals, and there's a blinking box next to it. Okay, in that spot, you're going to type in our equation. Okay, so our equation was 146. Now, we can't use C. We are going to have to use X because your calculator is not as smart as you. It does not understand that we mean a variable when we say C. Okay, and your X button is actually located right next to the alpha button. Okay, so if you look on your screen, it's right next to the alpha button. Then we keep going. Plus 30,000. Okay? So that should be in our Y equals screen. After that, you're going to hit second again. And then you're going to go to the other side of where that Y equals screen was. And you're going to press the yellow graph button. Okay? So make sure you hit second first. Then you'll hit graph. And you should see a chart pop up. Okay? And that chart shows you all the inputs and outputs from this function rule, okay? And you can use your arrow keys to go up and down to find the C values that we want, okay? So if you look at our chart, at 0, you should see 30,000. Then use your arrow keys to go down until you find 10, and you should find 31,460. Then go down to 20, we see 32,920. And then lastly at 30, we see 34,380. Okay? So that just makes it a little easier. 2 ways to do it. Okay, I will not give you these steps on a test. Okay, however, if you forget how to do it, you know you can just plug it in by hand. Okay, all right. So now it comes time to graph. When we graph, notice what we're going up by. Okay, we're jumping big, so I'm going to go up by 10s or by 5s, probably rather. Yeah, like this. Okay, so I've got 10, 20, 30, 40. And then up the side, I'm going to go by 10,000. So I have 10,000, 20,000, 30,000, 40,000. Okay? And let's just label it. So we've got feet cubed, and we've got weight in pounds. Okay? And notice, it does not matter what you go up by, okay? As long as you label it, right? As long as you label it, I'm happy, right? I can tell what it is you're trying to get at. All right, so now let's plot our points. We're going to have to eyeball them a little bit. So I have 0 up to 3,000. I've got 10 up to 31, so it's a little bit above. Then we have 20, 32. It's a little bit higher, almost halfway. And then 30 is just right below my new line there, okay? Connect my dots. There's my graph, okay? Now look at our next question. It says, what is the weight of the truck when it's empty? So in other words, when I have no cubic feet of concrete in there, how much does my truck weigh? Well, here's 0. My truck weighs 30,000 pounds, okay? So without anything in it, just my truck weighs 30,000 pounds, okay? Empty telling me C equals 0. All right, let's talk about some vocab. So today we're learning about 2 different vocabulary words. The first one is continuous. The second one is discrete, okay? And these describe different linear graphs that we have. The first one being continuous, meaning it does not stop, right? My line is going on and on forever. All my dots are connected, okay? By discrete, notice we have individual points, okay? They're not connected. Here's the difference, okay? Discrete graphs are graphs where I'm not able to have decimal answers, right? I'm not able to just continuously go from one dot to the next, right? There's some form of a jump that happens, okay? Versus continuous, I am able to have decimals. It's easier to understand this with an example. So for instance, let's go our discrete graph here. Let's say this graph is showing us the number of homecoming tickets or the number of students who go to homecoming per year, right? The number of students who go to homecoming per year. If you think about that scenario, could you have a decimal student go to homecoming? No, right? We can only have whole students, right? You can have 100 students go, 99 students go, 98 students go, but you cannot have 98.5 students go. Okay, so here it wouldn't make sense for us to connect any dots, because if we connect those dots, we'd be saying that anything in between them could also be a solution. Okay, but we can't have a decimal student as a solution. So that would be an instance of discrete. An example of continuous would be, let's say you're filling up your car with gas, right? As you fill your car up with gas, are you jumping from 1 gallon and all of a sudden you have the next gallon and then the next gallon and then the next gallon? Or are you doing it gradually, right? You have 1 gallon, then you have 1.1, 1.2, 1.3, 1.4 gallon, right? It's increasing over time slowly, but you can have decimals. That would be an example of continuous. All right, so let's just look at this first problem here, okay? So it says the amount of water W in a wading pool in gallons depends on the amount of time T in minutes, okay? All right, so again, practice with your calculator. So pause, type this in, see if you can fill in our chart using the calculator steps that we used above. And here they are if you need them. All right. So filling that in, we should have gotten 3, 6, 9, and 12, okay? If we were to graph these, we'd graph 1, 3, 2, 6, 3, 9, and 4, 12. Now think about our scenario. is this continuous or discrete? As I fill water, so here's my pool. As you fill this pool with water, right? Am I going to jump from one to the next? Or am I going to slowly rise over time and therefore have decimal amounts of gallons of water? Well, I'm going to rise slowly over time, right? So this becomes continuous. I can connect my dots. And I'm going to say it's continuous because our water fills consistently. I mean, there's no jumps. All right, try our next one. Pause our video. I want you to try the next one. I want you to consider if it's discrete or continuous. All right, so we should have gotten these values. Notice that I started at 0 because my N is talking about tickets, and it doesn't make any sense for me to sell negative tickets. So my first number was 0. I plugged in my values from my table. This is how I chose to label my graph. You could have done it differently. Again, as long as it's labeled, I'm fine. Okay? And now think about our scenario. N is talking about tickets. So can you sell decimal tickets? No, right? We can't. So this would be an example of discrete, and I would not connect my dots. Okay? All right. Last little bit here. We're going to look at some very special kind of functions. So if you look at number 6 here, you'll notice right away that I'm dealing with an absolute value. Okay, so I've got an absolute value now going on. Let's practice typing this into our calculator. So I want you at least right now to get to your y equals screen. Okay. And to type in our absolute values. Okay, so that's what these steps are for right now. Okay. We're going to plug in, we're going to follow some steps on our calculator. So if you start with the math button, okay, so if you click math, okay, once you click math, use your arrow key. I want you to go over to NUM. Okay, you'll see it up top, NUM. Use your arrow key. Then right underneath that, you'll see number 1 says abs, right? We all want abs. But that stands for absolute values. So if you hit enter or you push 1, you'll see these bars pop up and you can type in your X. Then you'll use your arrow keys to get out and type in a -4, okay? Follow the rest of our steps to find our chart. And you'll see that we end up with, we get a -2, -3, -4, -3, -2. So right away, if I look at this, I know that it's not linear, right? Because I'm not changing by the same amount. But let's just see what it looks like. Well, if you plot it, we're going to get some looking of a V shape, okay? Now, here's the cool part. If you go on your calculator and you just press the graph button, okay? So don't press second, you just press graph. You're going to see this graph show up, okay? So you can check your work. All right, I want you to pause my video and I want you to try the next two. Okay, so try the next two, punch them in, get the practice, draw your graph, and then hit graph to see if it checks out. All right, so we got, for the first one, we should have gotten values that look like this and a graph that looks like a U. This is called a parabola. Okay, a quadratic function. You'll spend a lot more time looking at these in Algebra 2. The next one, we plug everything in, and we're going to get something that kind of looks like a snake, right? And this is our cubic function. You'll see this a little more in Algebra 2 as well.